This presentation will help you understand and perform a present worth, or PW, evaluation for one project and two or more alternatives that are mutually exclusive. Additionally, it summarizes the evaluation approach for independent projects. Before discussing the PW method, the types of projects must be understood, as well as the types of future cash flow sequences that are commonly estimated. There will always be one project or more than one project to be evaluated. Initially, let's consider a problem with two or more projects. First, let's discuss the type of projects. When only one project can be selected from two or more, they are commonly referred to as mutually exclusive, or ME, alternatives, as shown in the upper left. Each alternative is pitted against all the other alternatives in the evaluation process. If more than one project can be selected, that is, if one or two or three or all projects can be funded, they are called independent projects. In this case, each project competes with the do-nothing or DN project, not with other projects. The DN project is the status quo. It has no additional cash flows or changes in the currently observed rate of return. What is there now stays, whether it is nothing or an in-place activity. The estimated cash flows for each project may include both revenues, that is, cash inflows, and outflows, that is, costs. This is called a revenue alternative. The only other option is a cost alternative. Here, no revenues are projected because they are assumed to be the same for each alternative. Performing a present worth method evaluation is quite simple, as shown here. As you read through this, you will see that all cash flows are converted, that is, they are discounted, to equivalent amounts of money at the current time. This time is identified as t equals 0 or now. The interest rate used is very important. It must be the rate of return required by the corporation or an individual to economically justify any project or alternative, and it is called the MARR, or minimum attractive rate of return. The MARR is also referred to by other names. Hurdle rate, benchmark rate, and cutoff rate are three of those. The conclusion to any economic analysis is the selection of the justified alternative for mutually exclusive, or projects for independent projects. These will be funded because of economic justification. Two guidelines for mutually exclusive alternatives are defined, as shown here. If only one project is being considered, the PW value is reviewed. If it is greater than or equal to 0, this indicates economic justification at the MARR that was applied in the computations. If PW is less than 0, then the MARR is not expected to be realized, and the project is not economically justified. For two or more mutually exclusive alternatives, as mentioned here, the numerically largest present worth value is selected. Note that this is not simply the largest value where the absolute value has been taken. The sign of the present worth value is very important. More on this in the next slide. Finally, if the project, or if there's more than one, the projects are independent, all of the projects with PW greater than or equal to 0 are acceptable, as they are projected to return at least the specified MARR. It's important to remember that these independent projects do not compete with each other, as do the mutually exclusive alternatives. Let's concentrate on multiple ME alternatives for this slide. The present worth method has a special requirement to be correctly applied. It is called the equal service requirement, as listed here. This means when the evaluation is done, each alternative must have the same capacity or capability over equal amounts of time. When alternatives have equal lives, as they do for this presentation, this requirement is no problem because it is automatically met. However, when the lives are different, a special approach is needed, which you can discover in later modules. Now, about that selection guideline of picking the numerically largest present worth value when two or more mutually exclusive alternatives are considered. What does this mean? Well, it means that the cash flow direction must be retained for revenues and costs. That is, sign is important. The absolute value of the present worth value is not taken when the selection is made. Here are some examples. We have shown the results of 4 different problems, and each has 2 alternatives. Look at these present worth values and write down the selected alternative for each of the 4 cases. Here are the right choices. A, B, B, A. Did you get them all correct? Note that the numerically largest always considers the sign. For example, in the second case, B is selected because the sign is plus on the 100. And for case 3, both signs are minus, but B is selected because minus 2,000 is larger than minus 2,500. Of course, if revenues are estimated for each alternative, when the PW sign is minus, the MARR is not expected to be realized, as we learned earlier. However, in some problems, it is required that one alternative absolutely must be selected for reasons such as safety, government requirement, or what have you. In this situation, the minus PW values must be compared with all other PW values. Case 3 is an example of such a situation where an alternative is selected, though neither one meets the MARR specified. Notice that both signs are minus, but yet we selected B because it has a numerically larger PW value. This example includes 2 equal service systems for automobile traffic control at a busy intersection, as described in the upper left box. The MARR is 6% per year. Revenues are not estimated. Therefore, the projects are mutually exclusive and they are cost alternatives. One will be selected. Vendor 1 has a larger first cost at $200,000, but it has a considerably lower annual operating cost at $10,000 versus $18,000 per year. The salvage value for Vendor 1 system is $3,000 after the 20 years of life. We will use a plus sign in the computations. Why? Because this estimated salvage value, which is at the end of the life, is considered a savings for Vendor 1 compared to Vendor 2. The lives are equal at 20 years. First, calculate the present worth for Vendor number 1 using the PA and PF factors as shown here. This results in a present worth value of minus $313,764. Perform a similar computation for the second vendor, and we obtain the number shown here of minus $331,459. Now compare the PW values. Which vendor will you select? You should have selected vendor number 1. Why? Because it has a numerically larger present worth value. Therefore, this means that economically, vendor 1 has a better system. If there are other considerations to make for the final vendor choice, these are likely non-economic in nature. They can change the final decision, but the economically justified choice in this case is vendor 1. This is the present worth approach in a summarized form. It is very commonly applied to compare both mutually exclusive and independent projects. However, as mentioned above, the selection of an appropriate MARR, minimum attractive rate of return, is very important to this technique. As always, we thank you for watching.